In our next section, we are going to see how we can get past networks employing open authentication. As discussed in the first video of this section, the mechanism used by open authentication is fairly trivial and can be circumvented easily. The only real case where open authentication can fail is when MAC filtering is in use. So let's see how we can defeat MAC filters, which in turn will allow us to bypass open authentication. Okay, let's begin. To sniff packets from our access point, we need to be listening on the same channel as the AP. So let's configure our monitoring interface to be in channel 11, if not done already. This is done via the iwconfig -0 channel 11 command. Before enabling MAC filtering on our AP, let's try to authenticate to the AP. This can be done by the fake auth attack option available within AirReplayNG. Here you can see that we have multiple options available to run the fake auth attack. At this stage we are concerned with the -E option only, which will be used to specify the network SSID. Okay then, let's run our fake auth command. This is done by running the AirReplayNG utility with a fake auth option, followed by the delay in number of seconds before re-authenticating to the AP. Here we will just use 30 seconds. Followed by the -E option specifying the SSID of the network we want to authenticate to. Finally we are going to specify our MON0 interface. As you can see, we have successfully authenticated to our AP. The fake auth attack will show the status of each individual stage. You can also verify this by checking the list of authenticated clients on the AP's management page. Our demonstration machine should be listed as a valid client right now. Now let's enable MAC filtering on our AP, whereby only one authorized client, in this case my cell phone, is whitelisted to associate with our test network. If we rerun our fake auth command, we will see that now authentication is failing. We can verify this in Wireshark also, that the AP is sending us back a non-zero authentication status, which indicates a failed authentication. We can also see that open authentication utilizes only 2 packets. Now the question is, how can we defeat these MAC filters? Once again we have 2 approaches, either active or passive. In the passive mode we wait for a legitimate client to transmit data on the network, and once this happens we can use that particular source MAC address to authenticate with the client. Remember that since the MAC addresses are transmitted in clear text on the wireless air interface, they can always be captured by anybody within the RF range. Conversely, in the active method, we will send a deauth message as shown in the previous video, and then gather the client source address. By sending the deauth message we force the clients to connect back to the wireless network instead of waiting for them to transmit data. Let's start by the passive approach. This can be done by launching the AeroDump utility with a filter for our AP's BSSID and channel. The bottom portion of AeroDump shows the current active clients on the network along with the BSSID they are associated with. Here we already have an active client on the network. So let's just copy this address from the AeroDump ng output and use it for fake authentication. So our command now becomes AirReplayNG --fake auth 30-E followed by our SSID test lab, followed by -H and then the source MAC of the legitimate client, and then MON0. As you see, we can now successfully authenticate to the AP. So much for MAC filters. Alternatively, we could have used the MAC changer utility available in BackTrack to change the MAC address of our WLAN0 interface to that of the legitimate client. This would also have allowed us to successfully associate and transmit data on the wireless network. This has been left as an exercise for the viewer. In this video we found out how we can sniff the wireless medium for MAC addresses of associated clients. Consequently, we associated as a legitimate client to the AP by spoofing our MAC address. Next we will look at how we can bypass shared key authentication.